millisecond is second
Yes?
over
Yes,
1000.
correct. There is post in the office for you. Interesting. Who's sending me post?
Yeah, I know.
Okay, are we ready for this one? No? A5 6. Lorraine's costume is always very good. Did you see the pictures of last year?
Can we see it later? We have chemistry class later.
I don't think she enjoys it.
No, I think she will,
will.
yeah.
She will.
Cool.
你知道这堂就好吗
No. No.
I don't remember it. Even
Did you forget to do your chemistry homework?
Yeah. Because there's too much at we have to study for physics.
Yeah.
You should have.
We love math and physics.
Okay.
We have to do it.
Right. A6. A rubber ball of mass 0.2 kilograms is dropped from a height h. The mass is 0.2 kilograms. It hits the floor with a speed of 7.8 meters per second. It then rebounds to a height of 2.5. So it bounces and comes back up then to 2.5 meters. It was in contact with the ground for 33 milliseconds. Calculate the h here. Alright, well that's U, V, A, T, S. Yeah? Well I suppose minus h since it's going down. So, what will I use here? V squared? V squared equals U squared plus 2A S. So S equals, what's it, 7.8 squared over minus 19.62. So H is minus S, which is
3.1.
3.1?
Yes.
Thank you. That's part 1. Oh. Huh? Energy? Yeah. Actually, would have that been quicker? About the same, I guess. What speed did the ball leave the ground at? So they want the U here for this part of the journey.
Yeah.
So part 2, U is U, V is 0, A is minus 9.81. Well, do you know what? Let's do it the other way since you suggested it, just for fun. The kinetic energy at the bottom must equal the potential energy at the top. So we get, that cancels to make a 0.1, and 0.1 goes into 0.2 2 times. So U is the square root of 5 times 9.81, which is, what's it, about 7-ish?
7.
Exactly 7?
Yeah,
Oh,
7.
3.
That's why I'm Stephen Hogan. Right, 7.003. You are no Hogan. Okay. What's next now? That was part 2.
But true.
Part C. What was the change in momentum? Okay, the change in momentum for which part? During its contact with the ground. So that's mv minus mu. That's mv minus u. That's 0.2 minus 7.8 minus 7.004. So that's 0.1 times minus 14.804. So that is minus 1.48 kilogram meters per second. Yeah, which I multiplied in. Why 0.3? Yeah. Yeah, multiplied by 0.1. Wait, why the heck did it become 0. What happened here? Oh. Terrible. So, minus 2.96. Okay, thank you. Kilogram meters per second. Was that it?
Yep.
No. D is what was the force exerted on the ball during contact with the ground. Yeah. I, of course, have this wrong. It's a plus because I wrote this in backwards. I mixed up my U and my V. Sorry about that. They're backwards. So it should have been 7.004 minus 7.8. Minus, yeah. So I'm just going to do it again. 7.004 minus 7.8. Okay, so that's a different number then, isn't it?
It is the same, just the sign.
No. It's a plus because this one is heading up. Yeah, and this one's heading down. And the minus is from the formula. Okay, so it's the same. So it's now a plus. Okay, so it's just a positive. Alright. And finally, what is the force? That is from this formula, which is 2.961 over, what was it, 30? Was it 30 milliseconds? 33 milliseconds, yeah. So that's 33 times 10 to the minus 3. So what does this work out as? 89.7 newtons then. And it's positive because the ground is pushing upwards on it. Yeah? Did you get those answers, Jerry?
No, I didn't finish.
Oh, okay. Is it okay? Is it okay now? Okay, write it down. Did you write it down? Yeah, okay, write it down. Got that? Yeah. Okay. No, Sean, you're writing, yeah?
The main part of December is 10% of our total salary, right?
10%. This exact day is not anything.
That's why I don't
What a good reason. Okay. Yes?